Hello everyone, this is Mr. O here. I've decided to try to pre-record this session because I might want to interact with you on YouTube. I think there is a comment box in the top right hand corner and you'll be able to ask me questions if you're not sure throughout this presentation. Okay, so we are going to start on topic 2.2 on the chapter on density. Okay, so as I've mentioned before, we're going to start on the topic of density. All right. And in this particular topic here, as you can see in front of you, there are 9 layers of liquid on the right hand side. This is what we're going to do in class. And I hope that we can just minimize this to maybe about 3 or 4 liquids because that will be sufficient. And you get the gist. These are the inquiry questions which I want you to think about throughout the entire session. Firstly, what is density? Second, how are regular and irregular objects measured? In this case here, we are dealing with 2 SI units, mass and volume. Lastly, how does density affect the floating and sinking of objects? Please bear in mind these 3 questions when we are reviewing this session. We all know about density, so it's time that we define density as the amount of mass contained in a substance per unit volume. Or we say that it's the amount of particles that one object can contain in a given space. And this can be represented by your formula density, grams per centimeter cube, which is the unit, and it is actually defined if you're talking about a formula, mass over volume. And how do we get grams per centimeter cube? Grams come from mass and centimeter cube comes from volume. How do we calculate the density for regular objects? Step 1, you need to measure the mass. So in this case here, we place the cube and the sphere on the electronic beam balance. Now, in this case here, don't be alarmed because it is only just a visual. Okay, so if you were to place an object on the electronic beam, you would definitely get the mass itself. But in this case here, I have already linked the particular picture so you'll be able to tell that I've used whatever I have from Google and I just made a reference to it. Secondly, after measuring the mass, you measure the volume. And the volume of the cube here is length times width times height. And the volume of the sphere is 4 out of 3 times pi times r to the power of 3. Now, I am not going to focus so much on the maths because the maths subject, it's a maths subject. I want to focus more on the concept, all right? And if you're given to calculate the volume, I will definitely provide you preambles or I definitely provide you the formula so that you'll be able to substitute wherever it is. The maths is only used so that you have a clear picture on the science concept. After measuring the mass and the volume, you calculate the density using the formula given, mass over volume. That is for regular objects. What about irregular objects here? You will still need to measure the mass, and this is a common factor between the regular and the irregular objects. So let's take this stone here, for example. If the stone is small enough to fit into a measuring cylinder, which is what we're doing in step number 2, in the measuring cylinder, you will put a certain volume of water. And that could be 150, it could be 100, depending, right? Once you drop the irregular object like this stone into the measuring cylinder, you will see that the water level has risen. Or in other words, we say that the water level has been displaced. The amount of water that has risen or displaced is actually the volume of the irregular object. And how do we calculate it? Assuming that your final volume is 180 and your initial value is 150, you take the final minus the initial to give you the volume of the irregular object. In this case, 180, take away 150 and that will give you 30 mils. Okay, so this is a measuring cylinder that we're using to calculate the density of the irregular object. All right. Sorry, not the density, to calculate the volume. Alright? After doing and calculating the mass and the volume of the irregular object, it's time for you to calculate the density, and you apply that formula. There is another question I want to ask all of you. How do you calculate the volume of a cork? Now, you will find out this answer and you will discuss this with me during class time. The other way of measuring the density of an irregular object is using a displacement can or a Eureka can. And yes, if you are from Archimedes, you will definitely know that Archimedes actually founded this principle, which says that the volume of the object is equivalent to the volume of the water that has been displaced. What they do in this case here is they will sink or immerse the object into the displacement can, and the volume of water that has been displaced from the can is the volume of the object. Note that from the regular and the irregular objects, the volume that we are measuring is in milliliters, and that's the volume of the water. But we need to convert it into centimeter cube. Remember, 1 milliliter is equivalent to 1 centimeter cube. Once you have done that conversion, you just apply the formula. Density is mass over volume, and you'll be able to calculate the density. But remember this statement here. The volume of the objects, oops, I'm just going to move this aside here. The volume of the object is equivalent to the volume of the water being displaced. As I've mentioned, density is mass over volume. But how do you remember it? I always like to use this triangle where you place the mass on the top, the density on the left-hand side, and the volume on the right-hand side. And if you need to calculate a specific unit, you will just basically cover it. So say, for example, if I'm looking for mass, I will cover the mass unit. So what you're going to do right now here is, if you're watching on your computer screen, you take your hand and place over the mass. So if I'm calculating the mass, you will see D and V. So M equals to D times V. We will see that in the calculation and you will know what I mean. Now, before going into the calculation, let us think about this concept of floating or sinking. Water, as we know, has a density of 1.0 grams per centimeter cube. Now, let's look at the left-hand side here where you will see a 7-layer column. You notice that water is in the middle, all right? That separates the first 3 layers and the last 3 layers. So if the object were to float and I were to drop it into this column, if it floats, it means it's actually less dense. So it should be around the levels of a lamp oil, rubbing alcohol, or vegetable oil. But of course, you know, in this case, which layer is the least dense? If you're thinking about the lamp oil, spot on. Which layer is the most dense? If you thought about the honey, you are absolutely correct. So let's try to summarize in these 3 sentences. Objects will float if it is less dense than water. Objects will suspend if it has the same density as water. So if we are going to try in our session next week, if it has the same level as the water, it means that it will suspend and it has the same density. All right. Objects will sink if it's more dense than water. What you need to remember here is the levels of different layers that you see will indicate the density. So if it's the vegetable oil the vegetable oil layer, we know that vegetable oil is less dense compared to water because it's sitting right above. But it is more dense than the lamp oil and rubbing alcohol. Same goes for honey. Honey here is the most dense because it's able to go right through the water itself. Okay, so this is just only an indication to you. It's not really an exact calculation, but it's a good indicator to tell you whether the object floats or even sinks. So why do objects float? We did mention it has to do with density. So This is just what I'm trying to show you, okay? We're using water here as one medium, and you can see the object. If the object here were to be on the top, that means it's less dense, and it floats. If it has the same density, it will suspend. That means it will just be hovering around here, okay? If it is dense, more dense than water, it will sink like the yellow box. Okay, this is something that I want to relate to you, but I will not be testing this, but it's good to actually have an idea on what it means by proportional relationship. Now, let's look at this formula here. If I were to increase the mass, if the mass goes up, all right, you notice that the mass is sitting at the same level as density. So there is a proportional relationship. It's a little bit of mass that's coming in. What it means by proportional is if one factor increases, the other factor also increases. Okay, so if one goes up, the other goes up. If one goes down, the other goes down. That is proportional. So remember the word proportionate. Proportionate here means the same. In terms of the volume change, let's have a look at where volume is placed. It's at the bottom, and the density here is on top. So if I were to increase my volume, and remember, this is an inverse proportional relationship. If the volume increases, my density will decrease. This makes sense. Volume increases means there's more space. So if there's more space, you have less particles in contact, all right, with that space around. So therefore, the density will decrease. Okay. So we will discuss about this in class if you're not sure of what the concept is like, but you have a general idea of a proportional relationship and an inverse proportional relationship, right? Inverse proportional here means if one factor increases, the other decreases, is going in the opposite direction. Time for some calculations here. Typical exam questions, but we have to dissect the question properly. I place the triangle here so that you'll be able to understand how you can remember the formula of density and when to use it. First question, calculate the density in grams per centimeter cube if a 50 centimeter cube block of aluminium has a mass of 135 grams. First thing we have to do here is always to list the units. So you have a look at the units here. 50 centimeter cube reminds you of volume. So V is to 50 cm cube. And the next one that you can find here is the mass, 135 grams. So if we have the mass and the volume, all we are trying to find out here is the density. And you got it right because the questions ask you to find the density. So density is mass over volume, 135 divided by 50, 2.7 grams per centimeter cube. Please be very careful because you need to use your unit. Grams per centimeter cube is for density. You may lose a mark because you did not put the unit. All right. So please be very careful. Please make sure that you also substitute the correct unit for the correct. Sorry, you substitute the no no not substitute. Sorry, you place the unit for the correct value. Okay. If it's volume, it's centimeter cube. It cannot be grams. Think about it very, very carefully. Example number 2. Object X has a density of 1.1 grams per centimeter cube. Determine the mass of the object in grams if the volume is 50 centimeter cube. Again, we list down the units. Density is 1.1 grams per centimeter cube. The volume is 50 centimeter cube. So how much is the mass? The mass is what we are trying to determine. Now, as I've said before, the triangle is very useful because now we are trying to calculate mass. So use your hand and cover mass. What do you see? You see D and V. So in other words, D times V. So let's go to the next step. You write down mass equals to D times V. 1.1 times 50 is 55 grams. Remember, the question has already given you the unit. So you must take care of placing the right unit to the right value. Okay? Last example. Determine the volume taken up by a wooden block if the density is 0.6 grams per centimeter cube and a mass of 0.72 grams. Again, I cannot stress enough, you need to list down the units. Density is 0.6 grams per centimeter cube, the mass is 0.72 grams. So what is my volume? Okay, so in this case here, what do you need to do? Which unit do you need to cover on the triangle? If it's the volume, you got it correct. So cover the volume with your hand. What do you see? You see mass divided by density. So volume is mass divided by density. You substitute the number into the appropriate unit and you use your calculator to calculate to 1.2 centimeter cube. Okay, so remember volume is in centimeter cube. Even if it's not given, you know that volume is in centimeter cube. All right, so your final answer should be in centimeter cube. Okay, I hope that you have understood what I have presented in this session, but we will go through it in class one more time. But at least you have an idea of what the topic is all about. Thank you for listening. Have a good day.